Where do LLMs store their data? Let's look into the key differences between traditional data storage and how large language models manage their information. Well, let's start with something familiar: relational databases. They are a series of tables that are related to each other, and within each of those tables are columns and rows. It's very intuitive. You can look at what's inside each table to see the data, and it will not change no matter how many times you go back to it, unless you change it, of course, but you get the point. Large language models are fundamentally different, so let's look into the technologies that make them different. The two big ones are vector databases and neural networks, and it goes without saying that there are no relational databases in large language models. Let's start with vector databases, which are a series of nodes connected together. The weight of the connection, or the proximity of the connection, decides how heavily related the nodes are from one another. In the case of LLMs, the nodes tend to be tokens, which could be a word or character or even part of a word. It depends on the embedding model that is used to embed language into tokens. For example, in a vector database for a large language model, apple and fruit might be closely connected while apple and car could be further apart. But now let's go into neural networks, which, if you've been a part of the AI hype train at all, you know a little about these already. The best way to think about these is that each dot is a neuron in a neural network, and the dots represent the relationship between these dots. A large language model is a layer upon layers of these neurons that is used to generate output from text. For example, when processing the sentence "the cat sat on the mat," neurons in different layers activate in response to various features of the text, helping the model understand and generate language. When models mention having 7 billion parameters, they're referring to the number of weights and biases in the neural network, which are adjusted during training to improve performance. Now let's put it all together. So let's say a human asks a question. The first step is the orchestration layer, which is responsible for coordinating the different components of the LLM system and managing the workflow. After that, the orchestration layer sends the text to an embedding model that changes the text input the human asks into an embedding that the vector database can coordinate with. So it sends the embedding to the vector database that then retrieves a bunch of data in the form of tokens from the vector database and sends that over to the LLM for processing. And all that data flows through the neurons, which generates text in the form of an answer, which gets sent back to the orchestration layer when it's finally returned to the human. So the answer is almost generated on the fly, which is why many people compare LLMs to a black box that you can't inspect. This is a general overview, but it's an important concept to grasp, or at least until the technology changes.